In this video, we'll be looking at the derivative of the cotangent of x. So we're looking at the derivative of the cotangent of x. What would that equal? So to find the derivative of the cotangent of x, we're going to rewrite this as the derivative of the cosine of x over the sine of x, which is, of course, exactly what the cotangent is, the reciprocal of the tangent. And then we're going to use the quotient rule, which says that the derivative of a function divided by another function is equal to the bottom function times the derivative of the top function minus the top function times the derivative of the bottom function over the bottom function squared. So let's apply this quotient rule to what we have here. So here we go. Let's take the derivative of the cosine of x over the sine of x in order to find the derivative of the cotangent function. I'm using the quotient rule now. So on the top, we have the sine of x times the derivative of the top. The derivative of a cosine is a negative sine minus the top, which is the cosine of x, times the derivative of the bottom. The derivative of the sine of x is the cosine of x. Okay, so now we have, and all of this is over. All of this is over the sine squared x. Now let's see what we have on top. Now, this negative sign can be brought to the outside, so we have a negative sine squared x minus a cosine squared x over a sine squared x. What I'm going to do now is I'm going to factor a negative 1 out of the top, and I have negative 1. On the inside we get sine squared x plus cosine squared x over the sine squared x. And do you see sine squared x plus cosine squared x? This, of course, is 1. So it's negative 1 times 1. So this is negative 1 over sine squared x. But 1 over the sine of x would be the cosecant. So 1 over sine squared x is the cosecant squared. This is the negative of that. So this is all equal to a negative cosecant squared x. I'm going to summarize the result by writing it down here. We have the derivative of the cotangent function is equal to a negative cosecant squared x.